In modern physics, the double-slit experiment is a demonstration that light and matter can display characteristics of both classically defined waves and particles. Moreover, it displays the fundamentally probabilistic nature of quantum mechanical phenomena. This type of experiment was first performed using light by Thomas Young in 1801 as a demonstration of the wave behavior of light. At that time, it was thought that light consisted of either waves or particles. With the beginning of modern physics, about 100 years later, it was realized that light could in fact show behavior characteristic of both waves and particles. In 1927, Davison and Germer demonstrated that electrons show the same behavior, which was later extended to atoms and molecules.
If light consisted strictly of ordinary or classical particles, and these particles were fired in a straight line through a slit and allowed to strike a screen on the other side, we would expect to see a pattern corresponding to the size and shape of the slit. However, when this single-slit experiment is actually performed, the pattern on the screen is a diffraction pattern in which the light is spread out. The smaller the slit, the greater the angle of spread.
An important version of this experiment involves single particles. Sending particles through a double-slit apparatus one at a time results in single particles appearing on the screen, as expected. Remarkably, however, an interference pattern emerges when these particles are allowed to build up one by one. See the adjacent image. This demonstrates the wave-particle duality, which states that all matter exhibits both wave and particle properties. The particle is measured as a single pulse at a single position, while the wave describes the probability of absorbing the particle at a specific place on the screen. A well-known thought experiment predicts that if particle detectors are positioned at the slits, showing through which slit a photon goes, the interference pattern will disappear. This switch-way experiment illustrates the complementarity principle that photons can behave as either particles or waves, but cannot be observed as both at the same time.
Is an electron light or smokeless fire? Either or, either or, either or. Either or, either or, either or. Either or, either or, either or. Either or, either or, either or.